Now we are going to see the implementation of the stack class. So for that we are going to have a Stack.cpp file where we have the stack implementation. The first thing that you have to do in a .cpp file is to include IOStream. This one will be used for the shift operator that is used to print things in C++. This is not necessary. However, if you are going to use the cout shift operator to print things on the screen, then you will need to have the IOStream. That is where cout and the shift operator are defined. Also, you will need to define this line using namespace std, because otherwise, whenever you want to use cout, you will have to prepend std : cout, right, to refer to the cout that belongs to that class. Then you include the stack.h, that is the header file for the stack object, for the stack class. That includes all the definitions. The .h file, you can see it like a contract between the implementer of the class and the users of the class. So the implementer promises that it's going to define a stack class with certain methods, certain parameters, and then the .cpp file is going to implement that contract, that header file. Then the first thing that we have here is the constructor. We have a stack : stack. This stack : what it defines is where what is the class this method belongs to, right? So that is why we have a stack : In Java, you don't need to do this because all the methods of a class that you define in Java, they are inside the class itself. Remember that in Java there is only one class file, and inside the class definition you have your methods, so you don't need to describe what class the method belongs to. In this case, in the .c file in C++, you need to define where what is the class the method belongs to. For example, in this case, the constructor receives the maximum size of the stack. You initialize the member variable maxStack with maxStack. In this case, it happens that the name of the parameter is the same as the member variable of the stack, so that is why we have to include this. This is going to be a pointer to the current object. So to access the member variable, we need to say this arrow maxStack equal to maxStack, so we assign the parameter maxStack into the member variable for maxStack. Then after that, we initialize the stack. Remember, stack was a pointer to the array stack, so we assigned a new array. This is how you create a new array with the size maxStack, and then assign it to stack. That is going to be the member variable for stack. Here we don't need this, because it assumes that if there is a variable that belongs to a member, that is the member variable of the class that we defined before, then we don't need to add the this. In this case, we use the this maxStack in here just to disambiguate that the maxStack was a parameter and also the name of a member variable. Then we have top equal to 0. So we initialize the member variables inside the constructor. Then we have the push method that is going to take the value that we will push to the stack, and then if top is equal to maxStack, means that the stack is full, so we just return false. Then stack top, we assign the value into the top of the stack, and we increment the top and return true. And then for pop, is going to take a reference to a value, so we expect a variable value to be passed into pop. And then if top equal to 0, that means that the stack is empty, then we return false. Otherwise, we subtract top, and then we extract the element from the stack that is at the top and assign it to value. Here this is important, that this value is the same as the argument that is passed by reference. So a variable that is passed here as a parameter is going to be modified with the top of the stack. This is something new in C++, and is an easier way to pass things by reference. Because in C++, if you remember, if you want to pass something by reference, you need to define that as a pointer in the parameter, and then you have to say something like star value equal, and then the value, so you have to assign it to whatever it is pointing to. Here is going to be more clear, I think, in C++, to define it this way. You define something passing by reference, so the variable that you pass in here is going to be modified, and then we return true, right? So that was the pop. Then we have get top, that is going to return the top of the stack. We here the const, that basically means that we will not modify the object. Then we have get max stack, that return max stack. Again, we pass it as const, and print. Here, this is how you print things in C++. We have cout less than stack, so it's going to take the string and print it, and then end of line or end L is going to be printed. Now, this is the standard way of printing things in C++ using the shift operator. You don't need to do it. You can use just printf, right, like you have done in C, and it will work as well, right? Which one is better than the other? Well, it is just depends on the programmer, depends on you, right, which one you prefer. If top is equal to 0, then print empty. Otherwise, it's going to iterate for I equal to 0, I less than top, I plus plus, and it's going to print I, and then colon, and then it's going to print the value that is in the stack, and then end L, that is the end of line, and then at the end it prints all lines. Now, so those are the methods. Now we go to the destructor. The destructor is going to be a method that is going to be called when the object is freed. Now, when is the object deleted? Well, you can actually, if you call new to allocate the object, you have to call delete. You can allocate also objects in the stack, like for example, if it is a local variable, then in that case, automatically the object will be deallocated at the end of the function, right, where the local variable is located, and then at that point the destructor will be called. Or also, if it is a global variable, if you allocate the object as a global variable, then it's going to be deallocated before the program exits. In any case, any memory allocated by when the object is constructed, or later on when the objects are called, has to be deallocated. So in this case, the destructor will delete the stack, because actually we allocated memory for the stack here. If you remember, we allocated memory for the stack, and that memory is going to be allocated, doesn't matter where the object is created. If it is allocated as a local variable, still this stack is going to be created in the heap. It's going to be created dynamically, so you have to deallocate it. Now, what is the penalty of not calling delete or not freeing memory? Well, the penalty is that memory will still be there, allocated, even if you no longer use the object. If your program runs for a very short time, that is not a problem. If your program runs for 24 hours a day, 7 days a week, that is a problem, because memory is going to accumulate, and the program will get bigger and bigger and bigger in memory until it starts to slow down, and you have to kill it and restart it, right? So the penalty is for long-lived applications, because it's going to use more and more memory, and at some point you have to restart it. And usually that is a problem. That is a problem in servers or programs that run in your computer for a very long time. Like for example, if you are implementing Chrome or an editor that runs for a long time, then in general it's important that you delete the objects that you are no longer in use. You have to be careful that once that you delete an object, if you continue using it, then that is going to be a problem. That is called a premature free, and that is a problem that is difficult to track. Okay.